So page 4 says find equation of tangent plane. So here we are on question 22. Tangent plane. So your function f of x and y is given as x squared y plus x, y to the third at the point 2 and 1. There you go. So first of all, we have the formula z minus z sub 0 equals to the partial derivative of f with respect to x at the point 2, 1, x minus x sub 0 plus partial derivative of f with respect to y, the rate of change of the function with respect to y in the direction of y-axis, evaluated at point 2 and 1 times y minus y sub 0. And remember that this point is x sub 0 and y sub 0, and z sub 0 is not given, so by plug that in, you can find your z sub 0. So z sub 0 is equal to, here if you plug in 2, you get 4 times 1 plus 2 times 1 cubed, which is just 1. So your z sub 0 is 4 plus 2, or just 6. There you go. So z minus 6 is equal to partial derivative of f with respect to x. It is 2x, here you have y, plus y cubed, times x minus x sub 0, which is 2, plus the partial derivative of f with respect to y. Here you get x squared, and here we have 3x y squared, y minus y sub 0, which is 1. Here we go. So let us evaluate the partial derivative at 2 and 1, evaluate partial derivative at 2 and 1, and then simplify our equation. So at 2, you have 2 times 2 times 1 plus 1, x minus 2 plus 4 plus 3 times 2 times 1, y minus 1. You get z minus 6 equals to, here you have 4 plus 1, 5. So you have 5 in front of x minus 2 plus, so here you have 6 plus 4, which is 10 times y minus 1. Now the rest is just algebra. You distribute 5 into parentheses, 10 into parentheses, and try to combine this. So z minus 6 is equal to 5x minus 10 plus 10y minus 10. So z is equal to 5x plus 10y. Here you have negative 20 plus 6 is negative 14. For question 23, we have another question asking about tangent plane. So let's just, I'm going to leave this formula here. We're going to use it again since it's asking about the tangent plane. So 23, tangent plane to the function f of x and y is equal to, here we have x squared plus negative 2 at the point 4 and 1. So again, z is not given. What's given? X sub 0, y sub 0 is given. So z sub 0 is equal to, we plug in 4, we get 16 plus 1 to negative 2 is 1, so z sub 0 is 17. So z minus z sub 0, or 17, is equal to the partial derivative of f with respect to x and evaluated at 4 and 1. So what's the partial derivative of f with respect to x? This side, this term doesn't have any x in it, so it is going to be just 2x. And then I'm going to plug in 4 here. Then I have x minus x sub 0 is 4 plus, then I take the partial derivative with respect to y and evaluate that at 4 and 1. So here you have x squared, the derivative is 0. With respect to y, this is going to be negative 2, y2. So remember that in taking the derivative, we're going to just reduce the exponent. So we subtract 1, negative 3 at point 4 and 1. Remember that you don't have any x, so we just substitute 1 here, y minus 1. So z minus 17 is equal to 2 times 4 times x minus 4. And here you have, if you plug in 1 here, you get just negative 2 times y minus 1. So z minus 17 is equal to 8x. I'm distributing 8 into parentheses minus 32 And here you have negative 2y plus 2. So z is equal to 8x minus 2y. I have negative 30. Negative 30 plus 17. It gives you plus. So here I have just 30. Yes, I get 30. This is equation of tangent plane. Well, let us answer question 24. Question 24 says, find points. Find points on the graph of z equals to 3x squared minus 4y squared, at which the vector n, which is given as 3, 2, and 2, is normal. 3, 2, and 2 is normal to the tangent plane. Normal to the tangent plane. So suppose you have a tangent plane. You're looking for points on the graph of the function where the vector n, 3, 2, 2 is normal, is orthogonal, is perpendicular to the tangent plane. Okay. This is your n, and you're looking for those points. Very well. First of all, let's rewrite this function so you can actually see all variables next to each other. Here you have 3x squared minus 4y squared minus z equal to 0. So this is equation of your function. Very good. Remember that when we talked about gradient, we said that gradient is very important. Why is that? Gradient as a vector is orthogonal or perpendicular to level curves. If you're working with a function in three variables, it means that it's perpendicular or orthogonal to level surfaces as well. So since we have a nice formula, we're going to find the gradient of this function. So gradient of f is equal to, so here you have 6x, negative 8y, and here you have minus 1. This is a vector, and you have another vector, n, 3, 2, 2, which is normal to the tangent plane. Very well. So what's the relation between these two vectors? Both of them are actually perpendicular or orthogonal to the tangent plane, level curves, level surfaces. It means that these two vectors are proportional. So suppose this is your gradient vector, but you're looking for those points, x sub 0, y sub 0, and z sub 0. So suppose you plug in x sub 0, y sub 0, you're not worried about z because it's just a constant. So here you have 6x sub 0, negative 8y sub 0, and minus 1. This vector and n, they are actually proportional together. What's the meaning of that? It means that they are scalar multiplication of each other. So if you write 6x sub 0 divided by 3, it must be equal to negative 8y sub 0 divided by 2. It must be equal to negative 1 divided by the last component of the vector of 2. Okay, as you can see, we can form linear equations and solve for x sub 0, y sub 0. So 6x sub 0 divided by 3 must be equals to negative a half. Negative 8 y sub 0 divided by 2 must be equals to negative a half. So let us solve each of them. In this case, if you just multiply this, x sub 0 is negative a 4. And in this case, your y sub 0 is equal to 1 over 8. So I expect you to ask, what is my z sub 0? What's the last coordinate here? Of course, you have a nice relation between x, y, and z. Plug that in and find your z sub 0. So we know that z is equal to 3x squared, so 3 negative 1 over 4 raised to the second power, plus here you have minus 4, subtraction here, minus y squared, which is 1 over 8 squared. So my z sub 0 is equal to 3, 1 over 16, minus 4 times 1 over 8 times 8. Well, let us simplify to 2. So z sub 0 is 3 over 16 minus 1 over 16, 2 over 16, or just 1 over 8. So the point is negative a fourth, 1 over 8, and 1 over 8. We found the point at which the vector is normal to the tangent